IPv4 public IP addresses have ran out, and as a result, we are forced to pay money for them. This is because whoever owns an IPv4 public IP address, they're simply renting them out to whoever's willing to pay. And guess what? If you want to have a server on the public internet, you need to have an address, unfortunately, a public address. In our last video, we talked about this problem, and we also looked at how IPv6 is the solution. It is the future. In this video, we're going to be taking a look at dual stack technology and how it allows your server to be compatible with both IPv4 and IPv6 devices. This effectively future-proofs your server. Join me as we take a look at how to do this. So let's dig into this and understand what it is that we're talking about by way of example here. So I'm in Excel just because when I thought about how I would explain this, I think Excel is going to be the best way to explain it. So in our last video, we saw that a IP address has 1 byte separated by periods, and there's 4 bytes. So imagine a period, 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 period. And what I've written here is, and IPv4 uses decimal. We saw that in the last video. And what I've written here is the highest magnitude IPv4 address possible. 255, 255, 255, 255. I am now going to do the same thing, but with IPv6, which has 128 bits, or 2 bytes separated by that colon, and there's 8 of them. So let's type that out. Okay, there it is, 8 of them. The next thing I want to do is I want to talk about what these values are. So let's get the calculator out. All right, so I got the calculator opened up here on my second screen, and what I'm going to do is I'm going to click on the 3 pancakes and switch over to programmer mode. And let's take a look at our Excel sheet for a second. What I'd like to do is I'd like to talk about what these values mean from a programmer's perspective. So 255, that is a very specific number, and as a matter of fact, if I switch over to the calculator and I make sure I'm in decimal mode and I punch in 255, it turns out hexadecimal, that is an FF. And if we look at binary, that is 8 ones. And you may or may not know this, but 8 bits go into a byte. So what this means for us is that this IPv4, these are byte values. So we get 4 bytes for an IPv4 address, and IPv6 gives us a lot more than just 4 bytes. IPv6 is written in hexadecimal, and we can clearly see how many bytes they have. So here is IPv6 rewritten. So rather than just writing 1 byte by itself in each cell, let's do what IPv6 is doing. So IPv4 gets 1 and 2. So here is our 255, 255, 255, 255. And what people started to realize was, hey, wait, this value here, I can make an address like this. In IPv6, I can make an address like this. What they started to realize was IPv6 can safely make that IPv4 address. So using the bytes available in IPv6, people started to realize, hey, wait, we can make all of the IPv4 addresses just zero out everything in front of there. Well, that's good. But now here's the problem with this. This is great. We understand that bytes hold numbers, and if you have 4 bytes versus 16 bytes, that's great. They hold numbers. You can put equivalent data in the 2 different formats because once again, it's all just ones and zeros. The problem with this is IPv4. We don't write our IPv4 addresses looking like this. we write our IPv4 addresses looking something like this with periods. So let me just write one down here. This is looking more like an IPv4 address. So the designers for IPv6 came up with a standard, and they decided that if you're going to map your IPv4 addresses directly onto IPv6, we need to have a special class of IPv6 addresses that are easily recognizable, that we understand, okay, I see what you're doing. You are simply referencing an IPv4 address under the IPv6 protocol because IPv6 can handle it. So what they decided to come up with is, we'll keep this. So actually, let me do it like this. What they decided to do was they decided to say, okay, if we are going to have a IPv4 mapped address on IPv6, then we want to have some leading bits here set to 1. So they want to have all of these bits set to 0, and then these bits set to 1, and then the IPv4 address. And then they also said, okay, let's do this. Just to make it really easy when we write things down, you are allowed to just write the IPv4 address right there. And so here it is. This is the IPv4, the mapped IPv4 address written in terms of IPv6. And this FFFF marks the fact that we are in that special range of values for IPv6 that are used for IPv4 addresses. It is just defined in that protocol. So 255, 255, 255, 255, this was helpful for us to understand what is going on here. How can they say IPv4 fits inside an IPv6 address? Why are they doing this trickery? And so that was a good example to start with, but now this is looking a little bit confusing. So let me come up with a IP address that you might recognize. So maybe something like this. So now you can start to see how this might be useful. Well, hold on, we're forgetting one thing. In our last video, we talked about shorthand for IPv6 format. And if you have sequential zeros, so sequential sets of all zeros, then you can replace it with a simple colon. So really, this address should be written more like this, because that's way too many zeros to write. So now that's starting to look definitely like how we're supposed to be writing our IPv4 mapped addresses in IPv6. One other thing to also note is that this special class of IPv4 mapped IPv6 addresses, the reason why we need that FF is because this is a range of values that are reserved. So what that means is that for these IPv6 values, so starting from 0.0.0.0.0.0 down to 255, 255, 255, 255. These are your range of values you can possibly have for IPv4. And so therefore, our range of values in IPv6 are going to be from 0 to 255. So this is a special class of IPv6 addresses that map directly onto IPv4 addresses. And the way we recognize that these are reserved addresses, and when I say reserved, that means you can't use them for anything else. These are representing IPv4 addresses. They are reserved. And so the way you identify it is if you have all those leading zeros, so 80 bits of zeros, and then followed by 16 bits of ones, the result is, this : FF, and then you simply write out your IPv4 IP address. The remaining 32 bits goes into the IPv6 address, and we are now able to accept IPv4 addresses in our IPv6 protocol. Before we jump into the code, let's take a look at the Linux Programmer's Manual. The link is in the description if you want to take the direct link directly to this page. And here we are looking at IPv6 protocol implementation on Linux. So if I scroll down here, there's lots of really good stuff in here. It takes a little bit of an investment to read into this, but if you do, there is lots of good things to get out of it. I'm going to highlight a couple of things, and then after that, we're going to jump into the code. Specifically, this paragraph right here on the screen. IPv4 connections can be handled using the IPv6 API by way of v4 mapped onto v6 address type, which is what we just talked about. Thus, programs only need to support this API type to support both protocols. That is awesome. Yada, yada, yada. IPv4, IPv6 share the local port space. So that means that if you're going to do this, your machine only has the ports that it has, and they have to share, whether you're IPv4 or IPv6. So let's scroll down here to under socket options, specifically this option here. I'm going to scroll out just a little bit. So IPv6, v6 only. If this flag is set, then the socket is restricted to IPv6 packets only. And then it says something else. I'll explain that in a second. Now, if the flag is 0, if the v6 flag is set to false, this socket can be used to send and receive packets to and from an IPv6 address or an IPv4-mapped IPv6 address. That is awesome. Now, here is the extra cool part. If we go down to the bottom, the default value for this flag is defined by the contents of this file. The default value for that file is 0 or false. So what does that mean? That means by default, when we write an IPv6 server code, we are having support for both IPv6 addresses and IPv4 mapped IPv6 addresses. So that means we are dual stack if we are running on the latest version of Linux. Now, it does depend on your installation. It does depend on what you're actually running. You may need to actually go in and edit this file. And another way, instead of editing the default for the system, is you can actually change this flag in your server code and force it, ensure that you are running dual stack. So let's take a look at the code. Okay, so here we are taking a look at the server code, and this is pretty much the same code as our last video. Link is in the description for the GitHub link, and you can go inspect it for yourself. I'm going to go pretty quickly here since we already basically beat this code into the dirt. We've seen everything there is to see in this code. There are some new commented out lines that you'll find under video 4 on the GitHub repository. I'm going to uncomment these lines of code here. And what we're using here is the git sock opt. And in a minute here, we'll just kind of take a peek at the... Actually, let's take a look now. So we're using the git sock opt, get and set options on sockets. So what this is implying already is that we need to have our socket created, and then we can start to look at what are things set to, and we can set those things. So link in the description for this if you want to take a look at this. So what this code is doing here is we are going to get sock opt on our server file descriptor for the socket, and we're getting under the IP proto IPv6, and that function parameter, that's the level. So there's many different levels. I don't think this one specifically lists out the levels, but what I did do was I went ahead and right-clicked and did go to definition, And here we can see some of the other level options available. So there's UDP, which we'll talk about in an upcoming video. There's all sorts of different interesting things that might interest you. So it's fun to just kind of look around there and see what different levels there are for a socket. But we're not going to spend too much time there. Then coming up next for the next argument is the opt name. So we're going to be looking at that IPv6 v6 only opt, which is what we saw on the Linux Programmer's Manual for IPv6. Here it is. We just saw that. And what we want is we want the opt val to come out into our opt val integer. And we want to know the size just in case if it's a large opt. Okay, so I have a breakpoint set here. Let's go ahead and save the code. Save the code and start debugging. And this is just on my local PC. In a minute here, we'll take a look at it on an actual server out there on the Azure cloud. So we did get address info. We did socket. We made our socket. We have our server file descriptor, which happens to be 3. It's just a handle. Let's, okay, I already have everything in my watch table here. To do that, you just have to right-click the variable and click Add to Watch. So let's step over initializing opt size. So we'll step over that. We'll step over int opt val. And here we are about to execute this function. We'll step over that. And we get return code 0. And we see our opt val is 0. And none of the variables changed here, but they would have changed after this function got executed. We got a RC0. So just so we know that this thing really did work, if we go down to head over to the get sock opt manual here, and we head down to, I'll use the link up here, return values. On success, 0 is returned. And so the return code stayed 0. We did not get a -1, so that means our results did come back, and it came back with a value of 0. So just to confirm that what this is saying is true, it's saying that we're checking if we're allowing IPv4 addresses, and we are. While I was making this video, I encountered something interesting. So I was working on the cloud demo portion of this video, and I wasn't able to get my IPv6 working. And I'm not using my normal computer for when I make these videos. So what I did was I headed over to this website, link is in the description, testipv6.com. And it does this check, and it says no IPv6 address detected. You appear to only be able to browse the IPv4 internet only. So to complete this demo, I'm going to have to switch computers over to my IPv6 enabled device. So we'll do that next. All right, let's finish this video out with a live demo. Here I am on the GitHub, and just like last time, this is still a work in progress, so I got to update that. But you go to the link in the description. It takes you to the video 4 folder, and you're going to have a deploy to Azure. Now, this button is different. This one is going to give you an IPv4 and IPv6 dual stack, and it is basically straight up exactly what you will find at this link here. And I'm not going to get into how I made this. Well, actually, technically I didn't make this. I just straight up copied the template. We're just using it for demonstration purposes. We're not going to get into that in today's video. We'll get into all this in a future video. All you need to do is click this button. It will bring you over to your Azure portal. Okay, and before we continue, I do want to just point out I am on a different computer now. And I can run IPv6, so we are good to go. We're all set for that, so let's close that back out. Okay, so we just need to pick a resource group. I'm going to select an existing one. I just keep using the socket programming resource group and then deleting it all out after the demo. you're free to do the same. The resource group just puts it all into basically a folder. Give it a username and a password. And I'm going to use the lowest VM size available. Review and create. And create. Okay, that is all done. I'm going to go to the resource group. And I'm going to SSH into the virtual machine. So I'll click connect. So here we are in the virtual machine. I am going to, same as last time, command is in the description. Going to install build essential. Okay, I'll type clear. So here we are back on the GitHub in the video 4 folder. Link is in the description. I'm going to select the server C code, and I'm going to click view raw, and that's going to give us the code here. And here's a cool trick. I'm going to take this URL, I'm going to copy it, and get back over to our terminal, and I'll type curl, paste, command line redirection with the greater than sign. I'm sending all of the text from this endpoint to server, and I'm gonna actually put underscore v6.c. And just like that, we got the code. That's pretty cool. So just like we saw on this manual page, let's look at what our default is set to. What's our default behavior? Let's copy that path to that file. Our default behavior is IPv6 0. The flag is not set. So default behavior is we're going to be dual stack by default. Excellent. Let's test it out. I'm going to start off our server. And he's running. We can see our IPv4 health probe with its IPv4-mapped IPv6 address, and our health probe for IPv6, which is actually using an IPv6 address. Those are connecting as clients to inspect our server and see if it's online. So with our server running, let's dock that guy over there. Back to our resource group, and let's find our IPv4 address. Here it is. I'm going to copy that, and if you recall, our server is listening on port 8080. So I'm going to open a new tab up here, paste in that address, colon, port 8080, hit enter, and it took a minute to load, but here we are. IPv6 server time is Friday, and we just used a IPv4 public IP address to connect to that IPv6 server. Very cool. And similarly, we can grab that IPv6 public IP address in our resource group, copy that IP address to our clipboard, and open a new tab. You have to put it in square brackets, so I'm going to do open square bracket, paste, close square bracket, colon, port 8080, enter. And once again, we can see that that is working. And so if I refresh this guy, we can see there is an IPv4 address. If I copy that IPv4 address, let's go to whois, paste that in. We can see that is my internet service provider, Cox Communications. And at the same time, if I refresh the page for IPv6, let's refresh the page. Who is this? Oh, I didn't get the full address. Let's take a look at who that is. Whoops, go back. Once again, it is Cox Communications. That is my internet service provider. Very cool. Let's go ahead and break the server by hitting Control-C, and it will close. I'm going to clear the screen, and let's bring back that curl command, and this time we're going to send it to _v4. So I'm sending it to a file called server _v4.c. Hit enter. And now we have 2 C code in this directory. I'm going to change the server v6 code. So vi server v6.c. And I'm going to come down to the set sock opt. And we're going to disable IPv4. And the way we're going to do that is we're going to set the option to 1 and uncomment all this code. Let's go ahead and build it. And let's run it. And what we'll notice is we're not getting our IPv4 health probe anymore. Let's take a look at what happens when we try to navigate to it. So this top one here is our IPv4 address. I'll refresh the page. And it's loading. While that's, can't reach this page. Meanwhile, let's refresh our IPv6 IP address, and the time just updated. So this is looking good. Now I want to show you something interesting. Back in the manual, it says that if this flag is set to true, then the socket is restricted to sending and receiving IPv6 packets only. And IPv4 and IPv6 application can bind to a single port at the same time. What? That's pretty interesting. So let's give this a try. This will be interesting. How do we have 2 applications running out of the same port? One's handling IPv4, one's handling IPv6. Let's try it out. So we're going to let this keep running. I'm going to open a new terminal, and I'm going to get connected again. So here I have a second connection. The first one's still chugging along. Let's edit our server v4 code. And what I'm going to do is I'm going to come down here and change the family from inet6 to just simply inet. Suddenly this is IPv4 code, and we'll keep everything else the same. :WQ. Let's build it. And let's attempt to run it. Wow. Okay. So our health probe is coming in. Oh, and look at that. Oh, I want to change one more thing. Let's shut this down. Let's go back into edit. Let's change that message that we're sending. I think it's at the top of this main. I want it to say IPv4. Okay, so it's back online. That's our health probe. Let's refresh the IPv4 IP address, public IP address. And suddenly it says IPv4. So this one is hitting our IPv4 application when we refresh. Meanwhile, this one is hitting our IPv6 code and our IPv6 application, binded to the same port 8080. That's pretty interesting. So right now, these two server applications are sharing the same port 8080, and one's saying, hey, I'll take your IPv6. The other one's saying, hey, I'll take the IPv4. Let's shut them both down. And let's edit the server v6. And let's comment all this back out. Let's build the v6 server code again. And let's bring it back up. So now this application is handling both the IPv4 and IPv6. Let's come back over to our IPv4 application and try to run it. And it won't connect. It won't bind to that port because that port is in use. Our IPv6 server code is hogging it all. This is pretty interesting behavior. All right, thank you for watching, and I'll see you in the next one. Take care. Bye-bye.